Okay, so firstly, we are going to cover about the error detection method parity. It is at slide number 15 in the lecture. Okay, so what is the meaning of parity? As I mentioned, this error detection is mostly used in computer network. So parity means that the receiver, after this data is sent through the computer network, is going to check some features to determine whether the data sent is correct. So if I continue with my story, it is like this. Hi, my friend. Whenever you have received a number, it should have even number of ones. Otherwise, it is not correct. That is a simple example about how to check whether the data sent is correct, and that method is exactly the same as parity. The name is a little bit strange, but actually the method is quite straightforward and easy to understand. There are two methods of parity. One is even parity, the other is odd parity. Even parity means that we need to send a number in which the sum of digits is even. As you know, in computer, the numbers sent are all binary. The sum of the digit is even means that the total number of the ones have to be an even number. At the same time, there is the method of odd parity. Odd parity means that we need to send the data which has the sum as odd, which means that the total number of ones, this value should be odd. A parity bit is turned on or off depending on whether the sum of other bits in the byte is even or odd. Because if we want to use this parity for communication, the receiver is going to check whether the number of ones, the total number of ones, is even or odd. Then from the sending part, how can we make sure to let the user to check that? The method is to add one parity bit. So the number sent out always follow the rule of the number of ones is even or the number of ones is odd. For example, if we decide to use even parity means that the total number of ones in the receiver side should be even. In this example, if we decide to use even parity and we are sending an ASCII number A, ASCII number A would be 7 digits in the low part as 1000001. Because the sum of these bits is even, we want to make sure the total number of ones is also even. So we add a parity bit in front of the number, which are the 7 bits. We add one number in front of it, and this is going to be 0 to make sure the total number of ones is even, and because we are using even parity. Okay, another example, if we are transmit ASCII number C, which is 10000011, then the parity bit would be 1. Because firstly, we are going to count the total number of ones. It is 3. As we are going to use even parity, we need to add a 1 in front of these 7 digits so that the 8-bit number has 4 ones, which are even number of ones. So as you can see, parity bit can only detect single bit errors. If during the transmission there are 2 values having problems are changed to its opposite, then the receiver would still, after the checking, thinking that the number is correct. So here we see parity bit can only detect single bit errors. Here is a good example which is written very detailed, has very detailed writing. If we decide to use even parity and we are sending the binary number 1000100. Then what should be the parity bit? There are several steps to achieve this. Firstly, we need to calculate the sum of the number, which is 1 plus 1. So here, the sum of number means the number of ones inside. In this case, it is 2. Then, as we are going to use even parity and the sum is even already, we don't need to add 1 to change it, so the parity bit is going to be 0. The number to be sent is going to be 0, 1, 0, 0, 0, 1, 0, 0. Okay, this is another example. Firstly, we say we are going to use out parity, which means that the receiver is going to trying to confirm the total number of ones should be an odd number. If we are sending this number 11101000, and then how can we add the parity bit before sending the number out? We firstly calculate the sum of the number is 4, which means that the number of ones is 4. Then, because we are going to use out parity, in front of this number, we are going to add a 1 to make it out. So the parity bit is going to be 1. The number to be sent is going to be this. It is pretty straightforward to understand, but on the whole, we truly appreciate this very clever invention. Even until right now, a lot of in computer networks, this is also still a very frequently used method for error detection. Another method of error detection is CRC, which is cyclic redundancy checking. Because first, for this method of parity bit, we are trying to make sure the data received has particular number of ones. And we can also use other criteria to detect whether the number sent is not changed in the transmission process. We are going to talk about that later on.